he has completed his ME in CAD with the same institution, Veltech Multitech. He completed his research program in Veltech affiliation with Anna University in the year 2013, and from then he served in various capacities in various institutions from principal to professor, etc. And he worked in Tamil Nadu Transport Corporation (STC) as a branch manager for 18 years since 1988 to 2006. I welcome you, sir. I am about to visit you.
First of all, I would like to thank for giving this opportunity to me for interacting with the wonderful session in the great days to our Professor Dr. M. Rajeshwari Madam. My lecture topics is interference of position and orientation and interference checking. This is included in 4th unit. The topic of the 4th unit is assembly of parts. Okay. Already the first 3 units are defined in basic features needed for design, and also the various features of the design. In post 4th and 5th units take assembly. Okay. The design is important for automated manufacturing. After designing, the design must be checked whether the design are improper or not. If the design are improper, that is the interference. Interference is nothing but this is some deviation from the position. When the position is deviation, the assembly design are getting some troubles, make some damages to the manufacturing. Once the design is completed, it should be simulated for checking the correctness of the design. After that, checking the orientation, the design should be implemented in the software manufacturing. Okay. That is very important, especially for the mechanical engineering or automated manufacturing environment. Nowadays, the manufacturing environment needed the competitive attention to give the quality parts, accuracy and the compactness and also the appearance. The product depends upon the computer for the accuracy. So we are going to discuss about the position and orientation in the assembly of parts, interference and interference checking. Next is already introduced by our professor. My name is Pagani. Here, associate professor in the Department of Mechanical Engineering since 2013 August. Next please. First, we are going to take just an introduction about our topics. The high-level entities, the mapping features and mapping relations are used to describe the composite state of parts in assembly. The high-level entities in earlier, in the starting of computers, the homogeneous matrix are used. When the homogeneous matrix are used for designing, it takes some large amount of input data and large amount of time, less accuracy. So nowadays, in the computer software environment scenario, high-level entities, that is a mapping of features. The geometry of the parts are used and the mapping relations are mentioned, defined in the similarly. And then the characteristics of volume of the parts, and the reference origin, where the parts are to be fixed, and the boundary phase. After fixing the location of the parts, an assembly having the number of parts, each and every part should be mentioned with the reference of origin, boundary phases. When we are going to include the solid, the phases, the boundary phases of mating features, and the features of parts are used to determine the automatic part position operation. When we wish to automatic positioning, the features are needed. Body, reference origin, boundary phase, mating features of the parts are very essential to getting the automated position. In area designer, use getting 4x4 homogeneous transformation matrix. Here the numerical data are used. And then because of the physical need, such a transformation matrix is difficult to understand. For get training, understand the software techniques, there is a very difficult, and the input data are quite larger. Next please. One important issue in developing the feature-based computer-aided assembly design is proven to convenient and powerful part positioning mechanism. It is needed convenient and powerful part positioning mechanism, and then using feature for part modeling. There is a graphical model. Nowadays, use the graphical model. Graphical model is nothing but the combination of the matrix as well as the feature of the diagram, feature of the design of parts. The transformation, matrix transformation is very important to execute the program, as well as in order to minimize the input data and the requirement of the shortest time, we introduce the graphical model. It is a hybrid of the homogeneous matrix as well as the features path modeling has come to be the key to integrating design and the manufacturing. Because once the design are ready, design are transferred to the manufacturing sector, no changes after that, because many difficulties and the number of losses, damages will be occurred. So after designing, the simulation is very important for checking the assembly of parts, getting any interference or difficulties. In feature-based model, the mating feature of the parts to automatically drive the position. Because of the transformation implementation, automatically the assemblies are getting in automatic drives of its position. Part features information may include feature names and the feature parameters. Already I told the reference point. These are the very important notable collection for implementing the position and the environment, the assembly of parts. Reference points. Reference point means the each and every part location with the coordinate, and then dimensions of the part, and the orientation. Orientation is nothing but it's a direction. After location, the direction of the part is should be mentioned, and so on, which can be applied by the feature-based part design system. Next please. The feature orientation is assumed to be parallel or perpendicular. The figure shows two parts. This is the assembly drawing. B, A denote the two parts. Part 1 is the cylinder, and then part 2 is the pole. Okay, this is the different mating part, female and male and female part. Now we are going to match. Here the designer only has to specify that cylinder. The cylinder and the pole is the the mating commands should be included according to the respective assembly needed. And then automatic part positioning, the positioning of the parts, various parts, and then feature-based assemblies. These are the process designing feature-based assemblies of initiate process. And then this is the flow chart, automatic assembly. This is the flow chart, the specific mating feature of the parts, and then determining orientation of mating features. The mating features, male and female part of the features should be mentioned according in the sequence. Orientation, mating feature. Orientation means the direction of the parts movement should be mentioned by the boundary face. The feature, the specific mating should be mentioned in the features, and the movement orientation should be mentioned in the boundary space. Determine location of the mating features by the reference origin, and then modify final position of mating features. If any interference occurs, finally the design should be modified. Next, please. The relations among feature, parts, and assembly. Before we discuss the part positioning, please need to the basic features. What is features, parts, and assemblies for our convenient understanding. The issues, there are three issues are there. Firstly, the first issue concerns the mating relations. We must be known the basic fundamentals available mating relations to complete the task. Is for easy distribution of the assembly process. Okay. Each and every process having the number of solutions. Which one is better for simplify our design concern. The design is space optimization. First, the space should be optimized. Number of parts should be assembled without any interference. The degree of freedom must be specified at limited space without interference. And the second is local reference origin. The local reference origin of the mating part and the features. And the third is the boundary faces. When we go into the solid space, solid features, we must be mention the boundary face. And then first one, we go into mating relation between the mating features. First issue, the mating relation is usually used to simplify description of the assembled state of two parts. Okay, whenever first we take two parts, male and female, now we are going to assemble one together, and then the simple descriptions. Low-level graphics indicate such as spaces in earlier by the homogeneous matrices, needed faces. The faces of the part, each and every faces. In case we take rectangular, three faces, and then square, four faces, depending upon the geometry features, and then center lines. Center line is essential for giving the direction movement of the parts, and then and so forth. Used to represent. In nowadays, in the current status, the fifth contact and the alliance are also integrated with the previous for improving the design software. These are some examples. A set of sample relations and the corresponding mating features. The symbol arrow indicates the orientation, the direction, and then the feature respect to right-handed coordinate system that defines the features. There are 8 set of sample mating relations. First, the symbol as the cylinder. Okay, and then circle. There is a female part. This is the male part. This is a protrusion. There is a male part. This is the depression called in geometry. There is a female part. And then with D bars. This bars is inserted in the bar case. And then with C cylinder. Again cylinder, a whole half. They will be depending upon the application. The half circuit. And then with D, half cylinders are also inserted in the circuit holes. And then with E plug are inserted in the U slot. Okay. And then with F, half cylinders are inserted in the half holes. And then contact. Contact means the step. Both steps are similar but male and female. And whenever we are arranging the chair in the room, number of chairs are inserted one by one. The chairs drawings are same, but we can arrange one by one, male and female. Okay. And then like this, the steps are 1 and 2, male and female, and the aligned poles and the poles. Another poles. These are the 8 features used by assembler drawings. In mating lesson, male mating features. Male mating features usually correspond to the protrusion features. Otherwise, in the technical called protrusion features and female features usually correspond to the depression features. And then, when the mating lesson consists of 2 depression, mating feature such types are earlier in last 2 decades, 7 and 8. Designer must specify its own act to the male mating features and which act as a female mating features. Must be specified during the assemblies by using the when 2 parts are to be assembled, the part containing the male mating features is called a male mating parts, and then other part containing the female mating features is called the female mating parts. When the features consider as space, any one set of pairs, the parts considered as solid. And then next, the volume of the pair mating features corresponding to the mating relation therefore 1. Already we have seen the 8 features. The followed spatial relations. All are in spatial relations. All the features should be placed with the reference of the coordinate spacing. That means the relations, 3 relations in the fluid mating relation, the pair of mating share same volume space. First consideration, the fluid mating relation needed the same volume space. And then contact mating relations, second one, does not share. The volumes does not share. And then aligned mating relation does not share the same volume, but aligned with each other. An object in an assembly can be positioned according to its location and orientation. Already we discussed it. The location and orientation are very essential part to assembler drawing. And then the object may be mating features. When the assemble, there is a measure. When we go to assemble the parts, the parts 2 pairs should be in the male and female, mating features. The location is decided by the reference origin and the orientation is decided by the boundary place. This is the very important. The location should be mentioned in the reference angle and the face sub-assemblies. This is the some sequencing needed for assembling the drawing in the space objects. Here the zeros, the points are indicated the reference origin, and also the reference origin for the mating features. And then the location of the object can be displayed with reference origin. The reference origin of the object is the point of origin right-handed coordinate system. All the softwares are designed in the right-hand coordinate system and the defined location in the space. To simplify the already we see in the diagram to simplify the automatic part processing task, assembly design, the initial reference origin of parts is set to the lower left corner in the feature based design system. In the right hand coordinate system, the starting point is the lower left lower in the base. The reference origin of the main pathing is used to reference origin of the newly assembled sub-assemblies. When completed a part in the assemblies, when we are going to assemble the next part, the reference origin, the reference of the newly assembled sub-assembly. The first part is the reference for the next assembly, the next newly part. As to mating features, reference origin is a predefined location. Predefined location for each type of mating parts is listed in table 2 here. Here we see the number of locations. Reference origin locations. This is a black. Black means the male and female part mating and the direction. This dot is refer the position and the ornament refers the orientation, movement of the parts. And then this is orientation type 1, this is orientation type 2. This is a reference part may be changes and the direction also changes. And the features type 3, type 4 for the cylinder. That is the features of the parts. And then the features orientation type 1 for this slot location. This is the some slot as the same like this is the first is the cylinder, second is the core, and then here this is the some slot various position and the various orientation, and then outward location for the another boss type location. These are the some examples for the orientation and the reference origins. Next. Here transformed form. The reference origin of a mapping feature represents a location by which the mapping feature can be located for the shown in figure 4. Because the mapping business unit is a reference origin of a feature and its associated mapping parts feature, the mapping relation and the reference origin mapping feature is transformed form. The transformed form is nothing but the equation. The matrix form is converted into the equation for the automatic transformation. Okay, this is the inbuilt of the software. Okay, according to our design, software design. And then the initial location, final assembly location, and the associated mapping part is placed at the proper location accordingly. And when the transformation operations perform the reference origin of the mapping features are propagated associated mapping part, the reference origin mapping part then relocated. And then in each mapping step, automatic part positioning task must be compute the new position, female part must be derived corresponding transformation operation. If matrices. The matrices should be contain the relative distance and the location of the reference part. That is informations. And then next please. The determination of reference origin female matrix part. First we are going to discuss about the how to reference origin defined in the female matrix parts. Retrieve the rotations. Retrieve the rotations of the initial reference origin associated matrix features. First and next the generate transformation operation. First retrieve and then come to become the starting. Initial, after completion, the initial is initiate to the next also. And then the generate transformation operation such that the female mating part can be set in the final assembly location. And then relation between the mating parts and the spatial relation. The different mating relations. Whenever we are going to assemble the number of parts in a single assembly, the reference origin of the mating features of the mating parts have the following spatial relations. The fit mating relations, the reference origin of the pair of matings feature will be at the same locations. And then for the contact and the aligned mating relation, the reference origins of the pair of mating features will not be identical. For the contact and aligned matings, fit matings will be the location, same location, but the contact and aligned matings relation, the reference origin of the pair mating features will not be identical. The final assembly location will be determined by the relative distance between the reference origins. That is a very important for the interference. This should be mentioned input improperly, the interference will not occur after assembly. Okay, during the simulation process. And then the orientation of the mating features for described in terms of the boundary space. This is the third consideration issues. Now we are going to boundary spaces. Here the diagram will state each outermost surfaces. Each outermost surfaces, 6 spaces, top, bottom, right, left, back and front. Each outermost surfaces of raw materials defined as the positional boundary face. And B is the depression. Depression features to reference origin is located on the outermost surfaces. Here the depression is represent the outermost surfaces, and then C the depression features to reference origin is not located. Here reference origin is not located in C, and the protrusion features. D is the protrusion features. Here in the figure 4 the B and the D are the male and female part. The boundary space concept is used to describe transformation operation for determining the orientation of mating features. When the transformation operation execute, the part move according to the direction mentioned in the program. And then boundary face is defined as one of the 6 outermost surfaces called front, back, right, left and top boundary face. The back type raw materials in the area in the diagram A. And then the normal vector of the boundary face is defined as the pointing outward. That is a normal vectors. Okay. And then the features boundary face can be determined by the feature type and the reference origins. And the boundary face of the depression features are shown here in B. Diagram B is the place on which the features reference origins located. And then for a depression in the diagram C, the depression features reference origin is not one outermost surfaces in raw materials, in outermost surfaces with a normal vector opposite to the feature orientation. Okay, some difference between the B and C. And as for a protrusion feature, transformation, rotational transformation to move the parts from one place to another by using the transformation to determine the orientation of the mating feature by different parts. For examples for this understanding, where the part with the whole features are shown in figure 5b already shown is to be combined with the part with the cylinder features. That is the cylinder features. The cylinder features D. This can be simply displayed rotation boundary phase of the whole features from front to back. That is, the orientation of the female part can be determined through the rotational transformation corresponding to the female mating parts features. That is a part the diagram B and D. Once the orientation of the female mating features has been determined, the orientation of the associate female mating part can be determined accordingly. The features and the phases should be mentioned in the simultaneously for the execution. Here the simple diagram denotes the blood and use rod assemblies. The two mating features with the boundary phase on the same projection direction. Here we showing the front view. The three dimension, the slice line is denoted the front space, front view of the object. In figure 6, the boundary phase of the two mating features are on the same front view and the path to be mated are decided orientation accordingly. Okay, it has a pro extrusion and the depression. So we must be mention the location and the direction for mating. And then this general spatial relation for mating feature can be applied all 8 mating features. In table already we saw in the table 1 8, the same features are applied for all the 8 features. Yes, next please. This is the direction numbers. Different features orientation types on each boundary spaces. The 8 boundary spaces already we saw in the diagram 50A. We split the further spaces, 6 spaces. And then in figure 7, a set of direction. Earlier figure shows the set of direction numbers. Numbers are also numbers. The direction should be mentioned in the inverted value numbers. Edges and the potential boundary phases that correspond to the orientation type mating features in table 2 already we showed to the facilitate computing the rotational angles of female mating parts when the boundary phase of the mating features are same projection direction. And then direction numbers on each boundary phase are assigned counterclockwise. Already we told that all the transformation takes place in the counterclockwise direction. Also here from 1 to 4 and the upper edges boundary phase in the normal coordination system is assigned to number 1 viewed from the outside of the raw materials. The assembly part, these are the some issues. Now we are seeing the 3 issues of the geometrical features. Okay, now we are going to our positioning and orientation, position of the automatic positions. What are the transformation? What are the requirement should be followed in getting the automated assembly of parts? Here, the principle of automatic position approach we are first to make the boundary phases of the two mating features. That is the first. All the feature, the boundary phases should be mentioned, two mating parts. Okay. And have the same projection direction. And then direction, then the two places of reference origin of the two mating features are the same location. Okay. Number of parts will be there in the entire assembly, but we must be considered at the same time the two mating parts only. Okay. After completion of the two mating parts, another the first two steps can be applied to all the metric cases listed in step 1, while the last step can be applied to a different combination of metric features of the further considered. That is align and plug points. The step 1 details the steps are: step 1, rotate the female mating part. After location, the part should be rotate. But make the boundary faces of the associated female mating features coincide with the boundary face of the corresponding male mating part. There is a symbol when the female part is considered, the corresponding male part orientation should be mentioned. Before rotation, first translate the female mating parts to make the reference origin to female mating feature coincide the reference origin of the male part. Transformation is nothing but the matrix forms. All the data needed, the reference origin and the distance of movement and the allowances of two parts etc. all should be mentioned. Select the reference origin from the female part features, rotation center, and select the x, y, z axis of the rotation angle. X, y, z is nothing but it's a reference point. The rotation should be made from the reference point. The rotation angle used in the counterclockwise rotation. Counterclockwise rotation, the rotation angle must be moved by the counterclockwise rotation. After rotation, the female mating part is moved back to its original locations. And then the rotation axis of the rotation angle to determine the pair of places of boundary faces, the male and female mating features. There are 36 possible combinations. There are 6 by 6 possible combinations of boundary faces for the male and female mating features. Combination with the same rotation angle, rotation axis are clustering in the group. These are shown in the 10 groups for understanding. 10 groups of boundary faces, combination with corresponding rotation axis and angles. Here the groups are 10. The boundary faces combination, front and front, mating, that is a male and female part, front and front, back to back, top to top, bottom to bottom, left and left, right and left. The same spaces are to be assembled. The rotation angle, no need the rotation angle, that is a 0 degree. And then front to left to back, back right, need the 90 degrees. And then z direction, the axis is z 90 degrees. The same for another 10 degrees. X axis, y axis, z axis, x, y, z, y, z, and the radius direction 90 degree and the minus 90 degree and then 180 degree like this. The process of deriving the rotation axis and the rotation angles for group 1 and 4 is each pair of boundary faces in the first group as shown in table 3 of male and female mating features is identical. Two features are identical, thus the original mating feature associated with mating features are in the desired orientation and no rotation is needed. That is 0 degrees. And then group 2, the rotation in the female mating part 90 degree towards the counterclockwise direction. About the z axis, we will place the boundary face of the mating features on the same projection direction. Thus the rotation angle 90 degree for group 2. The rotation angle also 90 degree for group 3 and 4, but the rotation axis and the axis should be changes, x and y. Other groups can be explained in a similar fashion. The quick reference matrix. We come to for our transformation. Quick reference matrix for immediate response. The quick reference matrix is built up for easy retrieval for information on the rotation axis and the rotation reference matrices. This is essential for brought out in the system by the equation formula. And then the index B suffix x, B in M point is the boundary face of the mating parts. Now let us consider the point B notated with M, boundary face of the mating part, while B suffix F is the boundary face of the female part. Now corresponding elements of the peak reference matrix in the form Q. Here is denoted as the peak reference matrix. The rotation axis and the rotation angle are given in table 4. Here the P of M points front, back, left, right hand, top and bottom. Yes. The axis and the direction. The axis and the direction are mentioned. Axis and the direction. Rotation axis and the angles. Rotation angles should be noted for getting the peak reference. The transformation operation in step 1 can be summarized as here direction in negatives, the leftward direction, the negative denotes negative signs, the T is indicate the transformation operation, and X, F, Y, F and Z, F are the coordinate values of the reference origin of the female mating parts, and 0, 0, 0, 0 is the reference of the mating parts. Okay. The mating parts is fixed and the female parts is movable. Here we note the distance x, y, z. If the female part is brought out towards the male part for the assembly. That is the meaning. And then second, the R is indicated. Here the R is indicated indicates the rotation operations. The rotation axis and the rotation angles are obtained from the quick reference matrix. Step 2. The translate the female mating parts to male reference origin of the female mating features coincide with the reference of origin of the corresponding male features. In step 2, transformation operation. T delta x y z, where delta x is x into various options xm minus xn as like this, and the xm, ym and zm are the coordinate values of the reference origin and the mating feature. So for the mating relation fit, that is the mating fit A, B, C and D, the associated mating parts can be assembled using the following transformation operations. That is the equation 1. Now we have brought out in the equation 1 the transformation matrix T and direction, coordination, R is the axis, R is rotation axis and the equation remains in multiplication form. T multiply R and multiply T, where rotation axis, rotation angle equal to peak transformation of the matrix. Next. Step 3. Now we are going to come to final steps for brought out into remaining equations. Then according to the properties of the female mating parts, perform additional transformation of the female mating parts to reach the final assembly positions. Then some features with different orientation type. Okay, now in earlier we are discussing the same orientation, same size. When we are going to different orientation, different size, these steps are very guidance for getting the equations to be assembled using the mating relations with E and F conduct or aligned for the transformation operation are required. When we go for different features, the aligned and conduct These are the mating parts. After the two part positioning step described above, the boundary faces of two mating parts will be on the same projection direction. And then over the plug and U slot are same, boundary faces will still have 4 feature orientation as shown in table 2. Already see, sir. There are 16 possible combination of feature orientation for a plug and a U slot and orientation transformation must be used to fit plug and U slot features. There are 6 possible positions. And then the rotation axis determined by the boundary faces, plug features studied. The rotation axis and the corresponding boundary faces, different features orientation. Back and front y-axis, and the right and left x-axis, top and down y-axis, and the positions. And then next please. Meanwhile, the rotation angles after positioning, the part should be rotate. If the male part is fixed, the female part should be brought up towards the female part. The rotation angle should be determined by the combination of different features orientation, plug and U slot, and the boundary faces of the plug. The 60 combination of the features orientation are grouped into 4 groups. Into simplified, the 16 possible combinations are brought up into 4 groups in table 6 according to the rotation angles and the boundary faces of the plug. Summarize 4 groups of the feature orientation type plug and U slot. The TM is the direction. Here the TM is the U slot. Here the direction are given here. The TM is the direction numbers of the orientation type of plug. TM is the direction number of the orientation type of U slot. From the table, previous table, we can write the equation, the following equations for the designed rotation angle when BF of plug is back, right and top. Rotation angle is equal to TM minus TF in the direction angles and the added angles with the bound direction. This equation execute the movement of the male part. And then another one equation needed. Thus similar equations for designed rotation angle front and left direction. Only the directions are changed. TM minus TM. In the previous TM minus TF, here the TM minus TM. The same. Next please. After analyzing table 5 and 6 and also equation 2 and 3, we summarize the rotation axis and the rotation angles. Rotation axis and the rotation angles corresponding to each of the boundary faces of the plug features. Table 7. Rotation angles and associated rotation axis and the rotation angles corresponding plugs here. Back, front, right. This is the side and rotation angles position and the rotation equations. All 3 equations for the automatic execution to execute the program in the software. Therefore, when the 2 mating features and the associated mating relations are specified, proposed approach can automatically generate transformation matrices according and can assemble the parts properly. Determine the feasibility of assembly to check interference between parts volume is done by the solid modeling system. After designing and assembling, before implement the manufacturing environment, the design should be simulation for it, check it, correction, check it, proper corrections. And then interference checking, just what is interference checking? What is the essential for interference checking? In order to ensure successfully assembly, after assembling, it should be ensure successful formation. It is very important to avoid part to tool interference. Part to part, sometimes the part is is same, but tool is interfere in the manufacturing environment. So the tool slate also should be positioned properly in the assembly operations. Such interference can damage the parts, also the tools. We have developed an agent that will detect part interference in the assembly build during assembly operation and allow designer to either modify the design or change the assembly plan. Recommend to the it should be cleared in the simulation period. If any interference occurs, the design should be changes or edited. This is just a difference between the initial configuration interference. The diagram shows this is the initial configurations. Interference just touching the parts, two identical parts. The real world problem assemblies tends to contain a large number of parts each with complicated geometries. For most interference checking algorithms, performance requires rapid with the increasing the number of parts assembly and number of phases per parts. Most assembly design planning problems exhibit several levels of nested combinatorial explosion, making scalability and important research topics. Computation time for detecting interference depends on the size of the geometric models. This is the interference depends computation times, let's say executing times. And then quite often geometric models can be simplified before interference checks. Models can be simplified. That is a improvement of the models, solid models according to the automated design for manufacturers. Checks by using hierarchical approaches. The hierarchical approach already we have seen. The hierarchical is combination of the feature based and the homogeneous matrix based. Individual parts because both are having the number of advantages. In order to getting the both advantages in a single software, the hierarchical models are implemented. For instance, checking for interference between the boundary explorer of parts can be first test for part-to-part interference. Only when the boundary boxes intersect do we then need to proceed a more complex test. Thank you very much.
Nice to see you people here for attending a 7-day program on CAD. Really nice. I was invited long back and due to several reasons I was not given clear information from the department, and lately maybe on Friday I was able to sit and prepare a few slides for you people. Of course, this has to be delivered without any slide. Faculty development program, the lectures will come over here. I should be able to deliver without any slide or anything. It has to spontaneously come from the mind. But due to several reasons and several stress and intonations or whatever it is, we are unable to deliver it right. So we need assistance from the PPT and other electronic gadgets. Why don't you please come forward, because come and sit here. Because every time we tell the students, hey, come sit in the front. Dr. Palli sir, that will be more informal. Why you want to make it more formal? Let's try to move forward. So I was going through this CAD/CAM and I found that it is into core manufacturing and with the help of assistants. I find it a little difficult to talk from here. I feel like anyway. Sir, okay. So yeah, so fine. How many are CAD here? ME CAD? Area design, okay. Others are all thermal engineering and production. CAD. So anyway, it's one of the important topics in manufacturing and also related to highly advanced engineering. In manufacturing, we go for highly advanced and computer addition is important. Every day the technology is growing up, and the aided design and the technologies we are able to manufacture. And a lot of limits are there, lots of variations are there, lots of manufacturing methodologies are there. We have to understand, and in order to go for a precision engineering, we have some mandates. One of the mandates is tolerance analysis. When we talk about fits and tolerances, I hope you should have studied about clearance fit, various other interference fit and other things. Parameters are taken into consideration, and these considerations are analyzed. Now we get into the topic of tolerance analysis. Why we have to go in for tolerance analysis? What is the need? Why we have to maximize and minimize? What are the limits and conditions? How to analyze? There are lots of tolerances or lots of fits, and from that, how we are going to analyze, how we are going to optimize. This is the major section. Tolerance analysis talks about how to determine. So there's a definition and all that. When we go into the definition, So tolerance analysis is defined as a process of checking the tolerances to verify that all the design constraints are met. What are all the design constraints? Why we have to go for all design constraints? Can you tell me one or two design constraints? What is a design constraint? Okay, tell me what is a constraint? Some difficulty. What is a constraint? I have a constraint. What is a constraint? My communication is a constraint. That means I am not able to communicate well. My commuting from one place to another is a constraint, right? So what is a design constraint? A constraint is nothing but the individual word. The meaning is a difficulty in design. So there are a lot of design constraints. Tolerance analysis is defined as a process of checking the tolerances. Already we have spoken about, or we have learned about what are all the tolerances and what kind of tolerances should be given, and from there to verify. We are going to verify and analyze whether this is correct or not, because lot of bad samples are there, individual samples are there. From there we have to come. I don't know whether to choose. I am manufacturing per shift. I am manufacturing about 300 components. In the same CNC machine I have programmed it, and I am not able to get out of 300, about 250 are okay and 50 is getting rejected. So what am I going to do in order to optimize it? In order to, whether to give the exact, or whether there is a tool difficulty, or whether it is a design constraint, or what are all the various constraints that we are going to see in order to optimize the result. Why I have to optimize the result? Why I have to optimize the result? Can anyone say? Why I have to optimize the results? I am getting about 300 components. In those 300 components, even if one is defect, then there is a loss. The cost is somewhere there is a profit loss or whatever it is. So I have to get those 300 components as I like it or as I want it. So the manufacturing quality and the system has to be generated in such a way that we need to verify and find out, and where are all the constraints that we have to choose and stop it. So design constraints, verify that all the design constraints are met. So these design constraints have to be clarified and they have to be met. That means what? They have to be analyzed and checked so that there is absolutely no end result should be 100%. We expect 100% result. Whereas it may be 99 or 95 or 97 or 98, so we go for the higher order. So tolerance analysis is also called as a design assurance. So when we go for the design assurance, basically it is also called as the design assurance. When we go on the product, this comes under product design and development, where we go for the steps of design or stage gate development process. From there we take it forward, and the design assurance is given in such a way that there is absolutely best for the manufacturing methods are chosen the best in order to get the best profit out, or the best manufacturing of the batch, or we can say 100% expectation is there. What is the objective? While we are going for a tolerance analysis, we saw the definition, and what is the objective of it? This is to determine the variability of any quantity that is a function of product dimensions, called as design functions. So design functions are there, DF, and the variability of any quantity that is a function of product dimensions. The dimensions are taken into consideration, and we are going for the analysis. Product dimensions and variables that control the behavior of a design. Product dimensions and variables that control the behavior of a design function is called design function variables. We will all see what are all those things. This may, you may feel that it is a jargon, words are used, or the same kind of words are used where you will find it a little difficult to understand. But still, design functions, design constraints, design functions, and design function variables. What are all these function variables? There are examples, one or two examples which we have done, and I'll be able to show that. See, for example, I have taken the design function. F is the design function. I have got a block. These two blocks are of different sizes, which is placed in one rectangular block. And F is the design function. And the distance between these two blocks to the end is D1. I am giving a dimension. These are the product dimensions. And D2 is another product dimension. The second one, this is the D1. From here to here is the D1. I have it, and D2 is from here to here. And this is the F function, design function. And from here D3, this is the dimension. I can have as many dimensions as possible, and the basic thing is how we are going to the F design function. We have to decide with the help of the other functions D1, D2 and D3. Now F is called so D1, D2, D3, and F if it is greater than or is equal to 0, accept assembly, and if it is less than 0, then reject assembly. A very simple rule that states that if these two blocks, in order to design F, we have to go in for the D1, D2, D3, and hence if it is more or equal to 0, accept assembly, or if F is less than 0, that means what? It cannot get inside, right? So reject assembly. Like this, there are several applications where this is the base that we are going to see, D1, D2, D3. Like this, there are several dimensions which we will be giving it, right? What are the tolerance analysis? Because when I keep talking about tolerance, fixed tolerances, that will itself take a lot of time. So we go for the various, I have written it. See, there are various, this and all is, I just wanted to browse through and I just wanted to give you. So the nominal size, batch size, basic size, actual size, and the tolerance is the total amount of all this that we tell to the people. Is the total amount by which a dimension may vary, and what are the permissible limits, right? All this. And the bilateral tolerance, unilateral tolerance. What is bilateral tolerance? We give it on both the directions. Unilateral tolerance, we give it in a single side. If it is plus or minus 0.000, the other thing may be plus or minus 0.00 for the unilateral tolerance. All these things you know very well, as this has to be addressed only for the students. And what is allowance? So allowance, the maximum material limits, all these things you know. Just these are the clearance fit, loose fit, and free fit, medium fit, all these things. And in transition we go for a snug fit or rigging fit, and then the interference fit, tight fit, medium fit, all these things. And maximum material conditions according to the allowance, maximum material condition are least, material condition, LMC or LMC, all these things you know. Before going for this, those you should remember and take data from there. From there, we go for the tolerance. What is this? Why we have to analyze? What are the types of tolerances? Worst case arithmetic method, worst case statistical method, and Monte Carlo simulation method. That is, large number of samples are required in this place. And other methods, Monte Carlo is for 2D and 3D also. Other methods, Taylor series method, quadrature method, these are the two statistical other methods. Large number of samples are not required in this particular statistical method. And Rogers-Jerkis method uses concept of tolerance chain and can deal with general 3D problems. Taguchi method, you know, many of them have done projects in PhD in this Taguchi method, and based on principles of experimental design. So single, let's say, ascent ratio, single design function, signal to noise ratio. So when we go for this one, what is worst case arithmetic method? And this is for, especially this area is, we can use it for doing research in manufacturing. When we take one simple area, one single area, that itself will be the application and we can do research. Taguchi method, many people have taken it and they have done research on this, and they have come out with the application either in machining or drilling or any parameter is taken or any function is taken or any operation is taken, and this is done on that. Worst case arithmetic method. And so we use, what is worst case arithmetic method, what is statistical method. If there is, I can just draw it and explain. I can draw and explain.
Board is removed.
Board is removed.
Board was taken to ground floor.
Okay.
It was there until yesterday.
Okay. So I am lucky or unlucky?
Unlucky.
Okay, anyway. See, these are all the problems, it's all problematic. And unless and otherwise we draw something and show something, I found it very difficult to make this one. And no time and sitting and doing in Word is impossible. And also whichever computer we go, this everything is, we have got a lot of constraints. Because of all these constraints, we find it very difficult to, yes. So arithmetic method. When we talk about design trees, how many of you know about D trees and D chains? D trees and D chains. No idea. So, yeah. When I take a shaft, let me show this. I don't know. Where is the board is arrangement?
Arrange.
Please see, because it's possible, otherwise I should also not move from this place. So in this worst case arithmetic method, a kind of, if I want to machine the shaft with different dimensions, I say D1, D2, D3, D4, D5, D6, and a D chain is made based on the operations. The D chain will tell about the total length of it. Suppose it is 56 and the axis, the movement, and then what are all the directions where the tool moves, and what is the measurement that is being taken, and we go in for making of this kind a D chain. So this tells about this. This is a very simple picture, and this picture we have different dimensions. And these dimensions we have step turning and all that, and we have about 6 dimensions, say for D1, D2, D3, D4, D5. And the function, I have taken one as the function in between. That means what? When I machine from that side, when I machine from this side or turn from this side, automatically that function has to set it. So that means there is no operation there, right? So the design function is, I consider that as F, which you can see it here. So this is F, right? This is F. Now with this, I am taking, this is called as the design chain. From here, this is axis, from axis I am taking 56 mm, and from there other reverse direction or this whatever direction it is, we are just making it, and this is called as a D chain. I am making a D chain and the arithmetic operation happens. The arithmetic operation happens and I am drawing the D chain and finding out what is the design function. Right, D1, D2, D3 I showed you, and D4, D5, D6. If I change D1, if it is F is greater than or equal to 0, then it is accepted. If it is less than, right, if it is, what is it? If it is or equal to 0, then it is accept assembly. If it is reject assembly, right? So the F is decided with the help of the design functions D1, D2, D3. Now this arithmetic method, we take data. What is arithmetic? Using numbers, right? So we take this data and we draw a D chain. Because for PhD, how many are doing PhD here? Only one. Okay. This area, tolerance analysis area, is a very good area where Monte Carlo simulation method and Taguchi method and other three methods can be used. You can work on manufacturing to take, and excellent results can be produced. And it is also very easy to do a PhD in this topic. So the arithmetic, so D chain is taken, that is the dimension chain. D chain means dimension chain. Chain is taken and the axes are studied, and then we go in for the after machining, the F or the nominal F, we call it as Fn. I have to write all that in fact. Fn is a nominal value, the nominal function, design function is arrived. And also from there, this is the tolerance information, 56 plus or minus 0.10 is the tolerance information that I am giving from this diagram. And the D chain is, dimension chain is made according to the tolerance information. And DF is decided, that means Fn is decided. And then we go for finding F max and UF, right? All these things we have to decide that. And D chain is made, the dimension chain is made, and another thing is called as a D tree. It is called as a dimension tree, where you see this D tree is also made in one single axis. See here is this is one single line, and I am mentioning all the dimensions D1, D2, D3, D4, D6, and where is the axis and what is the D6. What is this angle, right? So I am going to have a D tree here. The D chain, dimension chain and dimension tree will decide, and the data will be taken, and this method is called as the worst case arithmetic method, where you can go in for taking any number of dimensions, because there are a lot of design constraints. When these design constraints are taken, say I told you, design functions, the design functions and design function variables. When they go for, what is the definition? The design assurance. Design constraints are met and design assurance. So we have to assure and ensure that whatever we design or whatever we make, whatever we machine, it has to be according to the parameters. So the arithmetic method, anything that we take with various samples, we go in for the D tree and D chain, that is dimension chains and dimension tree. We make dimension chain and dimension tree, and then we go for the data. This is the simple or the method, the worst case arithmetic method. There is another method called worst case. I don't know why they have given worst case. I have no idea, because I also don't have any idea. Worst case statistical method. There's graphs are there. Let me tell you, we draw graphs. Arithmetic means we take only the dimension numbers. We deal with numbers and we work out with numbers and come with the final conclusion. What are all the conclusions? What is Fn? Fn, see, What I am going to do, worst case statistical tolerance analysis or arithmetic analysis. What are all the things we have to find? Fn, this is the nominal dimension. Fn, then Fmax, maximum dimension. Fmin, minimum dimension. Then Tf, that is tolerance on F, tolerance on F, that area. That is Fmax minus Fmin, Fmax minus Fminimum. And what is TUF, that is upper tolerance on F, upper tolerance. What is upper tolerance? And TLF, what is lower tolerance? So all these things we have to find out in the arithmetic method. Once any board is available, I can just write it, and some formulas are also there. So when you find out all these things, you have to find out. See, when I go for this one, this is fully like max only. Because I can simply talk, like medium and I cannot do. So this is F. Now what is Fn? Right? Give us some Fn. Fn. What is F? F max. F minimum. Then Tf. F max minus F minimum. Tf. And Tuf. At least 2, 3 you should be able to. So what is this we are going to find out? So this is sigma dA max minus dA, all this. So TLF, the lower tolerance. What is the higher maximum tolerance? What is the minimum tolerance? Upper tolerance, lower tolerance. All these things we have to find out whether this is cognitive or arithmetic method. Yes, arithmetic method. Now the same thing, the technology. We are going for the worst case statistical method. What is the statistical method? We take data, non-availability of, it's okay, no problem. No, it's okay. Because cannot, it will take another 3 hours for me to complete it. Let me at least complete these two, statistical method and this method. Okay, ma'am. So what we are going to find out, we have to find out this Fn, the nominal dimension, and the maximum dimension, minimum dimension, and the tolerance upper limit and tolerance lower limit. There are some formulae where we can work on it. So the general formula is delta is given, some formula is given. We have to work on this one. Now, the statistical probability. What is worst case statistical method? When you go through, I think you all have Ibrahim Zid book, right? All of you are having? Please, that is a wonderful book. Please buy one and keep it at home so that we can, every day we can take and go through it. We can try to understand what are all the concepts given there. And the entire book is, of course, we can take lots of PhD research topics from there. So that is a wonderful area. This is again, mass property calculation is also very, very important, which I can deal it with some, what is a mass property calculation, but still with some examples I can show you. Now going in for this worst case statistical. See, this is actually, FTP is not just covering the portions, or it is not, bringing some, giving some ideas where you can do some research. That is the main concept of going for an FTP. Or same the Ibrahim Zid book, if we keep repeating, it will take 20 days for us to complete it. And every explanation cannot be done. So that we give nutshell, we give everything in nutshell. What is the maximum possibility and where you can do the research and how well it can be taught. That is again there. Of course. So in the statistical method, what we do is, we go for the curves, the distribution curves, or the shape of it. It's a normal distribution, it's a uniform distribution, then quasi-uniform distribution, triangle distribution, and left skew and right skew. When we graph it, and we find out what is the final value of it, or what is the best way to go in for the analysis of the tolerances, that is as per the given data, like that. So with the normal distribution, when we see in the thing, the normal distribution, a normal graph is there. And when we go for a uniform distribution, the graph is completely different and it represents several data. And quasi-uniform distribution, the triangle distribution, and then we go for left skew. Left skew means it is little bit, the left hand side it will be skewed. That means it has got some, then it goes into negative, minus something. And the right skew is talks about the positive. So this is a polynomial distribution system we represent in the form of the graph. When the graph is represented, and it is very easy to find out again the same Fn, Fmax, Fminimum and TFL and TUL and all these things are found out, and we come to a conclusion, yes, that this is the tolerance analysis that is to be done. And we go for Monte Carlo simulation method. Large number of samples are required and two-dimensional, three-dimensional for the application. Two-dimensional, three-dimensional applications are done. So if we go for Monte Carlo simulation, there are several things that are to be done. There are various in two-dimensional and three-dimensional application it is done, whereas in arithmetic and statistical we go for the numbers. In statistical we represent in the form of a graph. We represent in the form of a graph. Monte Carlo simulation method, large samples are required and two-dimensional. Suppose you take a cube, simple you take one cube. The cube is 1% of tolerance is given on all sides. So f is equal to root of a square plus b square plus c square or 0.01 and into root of a square plus b square c square. So if this formula is applied, we will be getting for one single cube. We say 1% tolerance is given on each side. So it is very difficult. So the expansion is very difficult. So we are going for the Monte Carlo simulation method. There are other methods, Taylor series method, quadrature method. These are the statistical methods which we have not, I have not gone through actually. We have to go through it. There is but. And Taguchi method, it is again the SN ratios, the design functions. Taguchi method is you have to study, so that will help you out. I have not got any material. Because again that talks about the optimization. It's very simple optimization. There is no need for me to explain more. We take suppose drilling means we do some hundreds of drillings and find out which is the going for the optimization. So that is the, we call it as the signal to noise ratio. Everything is optimized. So the tolerance analysis talks about all these things. You can do better immensely on this Monte Carlo simulation and the Taguchi as well as arithmetic methods and statistical methods. Suppose you take any function, design function and you want to work on arithmetic and statistics, find out if there is any difference that can come. So these things can be worked out. So F is obtained by adding first the F elements called as increasing. You cannot. So the D chain defines a location related to another location. So D chain means one location defines a location relative to other location. Suppose I have drawn the x-axis from there 56, from there 20, from here this side 15, right? So there is a relative to the other location, a location relative to other location. So depending on this, from here also we will take from the left hand side or from the right hand side. This uses limits of dimensions to perform tolerance analysis. This follows a probabilistic distribution curve to a frequency distribution curve, and probabilistic distribution curve is assumed to be a normal distribution curve. The worksheet is, I have shown you the worksheet. So this statistical method will help you to bring out the difference. And here in Monte Carlo simulation method, two-dimensional and three-dimensional design functions are formulated, and the method is used whether Monte Carlo method is used whether the design variables are linear or not. And it is a wonderful area where you can do a PhD in case if because people are struggling to find out a real topic and try to do. And as mechanical engineers, we are simply saying, I want to construct one aeroplane and say that is a project. Or I want to design one already existing, whatever is available, because we cannot go and R&D, like, act like R&D engineers. This is the way, design of experiments, using design of experiments and this kind of areas only will help us to get a quick PhD. That is what is very, very important. And Taguchi method, as far as I know, about 100 people have done Taguchi method and they have got doctorate. The method operates by generating with computer random generation a large sample of assembly instance of the assembly model. Each generated assembly is checked to determine whether it meets the specified design constraint or not, whether it is required or not. Algorithm is generated and implemented into solid modeler and VREF or CSD, constructive models are analyzed. So when the algorithms are generated and it is done. Okay, so this is for till this one about if you are concentrating on all these three, it is more than enough. Arithmetic, statistical and Monte Carlo simulation method. Some of the sums are also given in the book, Ibrahim Zine book. If you want, I can give you. Otherwise, please you have a book, or if you are having, please go to the library and refer it and try to get some details on this. It will be very useful. Is there any CAD-CAM? ME CAD-CAM is here? ME CAD-CAM? No, sorry. The PG course. PG, you don't have PG here. So you will be teaching only maybe one or two, so one subject on CAD, one subject and basics only. All these 6 are coming? No. Now only you have CAD. Syllabus. Anna University. What BE? Anna University syllabus. But all these things may not come. So what is mass property analysis? These are the two topics. What is mass? What is mass? purchased by weight. To find weight, we need the mass. Mass is the amount of matter in an object or the quantity of the inertia of the object. When we go for interviews, they ask lots of very basic questions. Right? What is Newtonian fluid? What is non-Newtonian fluid? Spontaneously, what is mass? What is gravity? Anything. Suddenly if they ask, you may not be able to answer unless and otherwise it comes from the mind. Unless and otherwise it comes from the mind. Very difficult. What is volume of, they have given polypropylene has a density of 0.035 lbs per inch cube. Mass is equal to this much, volume into density. Using the volume from the previous example. So all the sums have been done. The mass property analysis, to put everything in a nutshell, let me tell you. When a product is designed, we have to assume the shape of the product, functionality of the product, and the surface finish of the product, and the mass that it contains or mass that it would contain. Right? So the entire thing added together, we say half a ton or 1 ton or 100 kg or 5 kg or 2 kg or 1 kg. The space has to contain, it has to have or it has to occupy that particular space. Otherwise, either it will be rejected or it will be, the product will be of, with over information, or the product will be bulged, or the product will be, cannot be accepted by the people. The consumer satisfaction may not be there. Ergonomics may not be there. Right? Everything starts with the mass. When you say, I am able to handle a phone which is about half a kg, will it be possible for us to handle the phone? What is the ergonomics of it? What is the space design, space constraint, space design of it? Less weight and very handy. That is what we call it as, use the term as ergonomics. The ergonomics should be very, very clear or very much designed, or the product designer should keep the ergonomics in his mind for designing each and every product. Suppose I say this chair is there. I am sitting, I have to sit. What is the use? Where it is used? It is used in the auditorium. How many hours we can sit on it? With comfort and without comfort. Now I am taking an individual data from all of you. Sir, Dr. Palli sir, how do you feel? Sir, I can sit the whole day without any problem. My body does not ache. Right? And what is the weight? Can I move the chair or not? Very simple. Right? And doctor will say, sir, I am able to sit for 1 hour. Then I have to go outside and come and again sit. Or I should go for tea and come back and sit down, then only my muscles will relax. And again I will ask an youngster, I am very, very comfortable, no problem. Right? I will ask another person. So each and everyone has got the feeling that on your own, how do I feel comfort? Ergonomics is based, and ergonomics, every small damn thing is designed only with the help of the ergonomics engineer. I am more comfortable wearing a spectacles. I am more comfortable to sit on this. Like that operation of machines. Mass comes from there, where I have to design. I am having a block diagram or a complete picture of all the components I have drawn, and I am deriving the mass what it would be. From there I go for the manufacturing process. What are all the ordinary machines I have to use? What are all the special machines I have to use? What is the mass would be? What is the total mass of the? If I am capable of taking this one to 10 kgs or 25 kgs, do you think I can ship this one at any time? During those days it can be used because ICs are there, they were using, we can use only it in the AC, right? Now we have got in every Every household we have got without an AC because ICs are made in such a way that they can withstand to certain temperature. During those days, ICs were made where it can withstand only about 22 to 26 degrees centigrade. And if it goes more, what happens? There may be problem in the product. Okay, that is one area. The functionality of the product. That comes into the picture. It has to function as well as required as and when necessary. Piston cylinder arrangement is there. The piston will be about 100 grams or 150 grams or 200 grams. For example, you say. The cylinder, entire cylinder, the piston, right? So the entire cylinder, what is the mass of it? How much dia it has to be? So only if we decide, we can go for the manufacturing process. So at that time, mass property calculation and mass property analysis will come into picture. This is again your product development area. This is very, very important. You can go for a selection, take a product. They say this is bulky. Why it has to be bulky? This is too much. Every time I feel when I travel in the train, every time I feel the train is too bulky, too heavy. Why we need such a big train and a heavy train, right? In foreign countries, or it runs in magnetic levitation, right? So maglev, we say maglev. And the trains are very light. Why it has to be so heavy? Why we want such a train? And why we are not capable of traveling in 3 hours instead of we are traveling 7 hours, 8 hours from Coimbatore or from other places? Why can't we travel in 3 hours? So everything it starts with the mass. Even this is a very good area. The size, weight, surface area and other properties available from a solid model are most often part of the design constraint you design must satisfy. See the words, each and every word is very important. I just tried to. The following are mass property calculations available in today's solid modelers. So we have got every damn thing in the system now. In the software we have got everything available. When you give a particular constraint, when you give a particular design parameters, automatically design and it will show in 3-dimensional what is the functionality of it or what is the mass property, everything it will be showing. So the volume, density, surface area, centroid, product of inertia, radii of gyration, principal moments, mass, moment of inertia, principal axis, everything is we get it in the form of software now, right? So in the design softwares or in the analysis softwares, we give the inputs and the output is very clear. And if you want mass, yes, the mass is 25 grams or 50 grams, right? The piston rings, the mass is this much. So it is very easy to calculate the total entire component. Volume is the amount of 3-dimensional space that an object takes up. Design engineers use this value to determine the amount of material needed to produce a part. So the volume is very, very important. So height, width and length. So you say 4 into 4 into 4. Volume is equal to 128 in cubes, right? Centimeter cube, meter cube, inches cube, anything. So it is the volume is in cubes. So we have, there is a small cube 4 by 4 by 8 and we derive the volume. So volume is the amount of 3-dimensional space that required. When I design, when there is a product, the product has to be kept in one place. So how to fit it, how to make it work. Functional design, I told you functional design. Functionality of the product, mass of the product, space occupying, the space that would occupy. If I take a mobile has 7 or 8 components, right? What can you tell me what are the components? LED light, then back cover, then battery, right? Then front cover, number, we dial those number pad, we call it as number pad. Then the display unit. We have got a PCB, printed circuit board, right? Then an LED is there. Okay? Speaker is there, microphone is there, speaker is there. Almost 10 components are there, right? And the charger pin is there, right? Charger pin. And we have got slots, 2 SIM cards can be fit. And we have also got, what is that, another one small Memory card is there, 32 GB or 8 GB. So we have to fit all this and also ensure that it is handy. Now we are having mobile phones big phones where the display is better but we cannot hold it. People are trying to find it very difficult, as if I am taking a A4 size notebook. People are taking it. People have also named it as notebook or iPad or whatever it is, but it is finding it very difficult. So there should be a phone where we can access it quickly and also it is safe, and the factor of safety, that means when I throw it or when it falls down from 1 meter or 2 meters, it should not have any breakage. If it breaks, then absolutely it's of no use. Nokia phones are the best examples, where even if we throw from anywhere, we can, and less disturbance also, because I don't have to see WhatsApp, I don't have to use any other, no camera, nothing. Camera is another area that is disturbing, WhatsApp is, yesterday I was traveling in the Nilgiris. Two fellows were the software fellows, they were talking. WhatsApp yeah, I don't know what they were talking. WhatsApp Makans. They were going on talking and they were coming, because everything is like, the absurd information or useless information. It's a totally disturbing sense. So we need limited. We are able to this computer, we can only 2% of the computer usage we are using it. We are not using the maximum. Are we using it to the maximum? No. We are using hardly 1 or 2%, not more than that. Either we type some thing or in the Excel sheet we take a student's data list, but are we really using it for research purpose? Very less, right? So the softwares are there, we use less softwares. So the usage is also very important. What is the utilization percentage of each product? When it is not used, why it has to be so expensive? If it is expensive, is it reliable? Is the product reliable? Is the performance reliable? Reliable performance should be there. For all this, we start with all this, volume and all the density. It's defined as the mass per unit volume. Is a different density is different for every material. A product design engineer should understand the density is different for every material and can be found in a machinist's handbook. So you have to go through the handbook very cleverly and clearly for the data. Surface area is another area. Nowadays surface coatings are very, very important nowadays, where we go in for reducing corrosion, reducing wear, tear, right? And additional machining or additional burring or additional work is not required on that material. Now we want everything to be manufactured. The moment it comes out of the mold, plastic injection molding machine, it is shiny. So it gives a glossy surface. The surface is clear. There is no additional work there in that. I don't have to spend too much of money on that for my surface finish. Whereas if I take a cast iron piece or some other piece, I have to go for additional operation, and I have to complete it, paint it, or do the spray painting or corrosion resistance painting. Then I have to paint it. So all these 4 or 5 operations are extra. If I go for the plastic injection molding machines or the plastic injected parts, ABS is a part which is used in almost all components, right from the small computer to big aeroplanes. That part, if we manufacture with the help of injection molding, the surface is very clear. There is no additional work done. So my cost of the material comes down. And also it is not heavy. We talked about mass. It is not heavy. It is very, very less. In aeroplanes, all the cabins are made of ABS plastics, right? You get luggage. Cabin baggage, we say cabin baggage. Everything it is almost like this. We have it is made of entirely ABS plastic. and there is no additional and the less massless. So we decide the surface area, the occupying and the surface area is the square dimension of the exterior surface. Now surface coating is also there. Surface area is important when determining coatings and heat transfer of a parts. You know very well. So this is some example is given. Centroid. A 3D point defining the geometric center of a solid. Do not confuse centroid with the center of gravity. Who is taking engineering mechanics? Who is handling engineering mechanics? Nobody is handling here engineering mechanics. You don't have the subject? Well, now I am also taking engineering mechanics. We are also getting confused. Don't worry. Engineering mechanics is one of the subject. It's a very tough subject. I could say for the first year students. There we are taking for second years. Now we have changed into first year. Second it has come to second year. It is very difficult to teach engineering mechanics. And I rate them as, even if you get 60%, I rate the faculty as a very good faculty. Because in that age, understanding so much and understanding the basics of this is very difficult. We are trying to focus on what is the complete basics of it, and engineering mechanics, as far as I am concerned, has to be taught excellently well. With a lot of devotion, otherwise it is not very easy for them to pass. And understanding the concepts, the moment they come in the first year, understanding the concept itself is very difficult. At least second year, okay, he will be little mature. And I wanted engineering mechanics to be separated into two, engineering 1 and engineering mechanics 2. Very heavy syllabus, the university. I don't know how is Anna University syllabus. So that there we can centroid, moment of inertia, right? All these things comes in. Translation, motion of translation, all this. A 3D point defining the geometric center. Geometric center of a solid. What is the geometric center here? I am just leaving it to you. You can take your own answers. Do not confuse centroid with the center of gravity. How to find out centroid? We have xy directions, and from there we divide it into, and we take xy direction and we go for the finding out the centroid of an object. The two only exist at the same 3D point when the part has uniform geometry and density. Oh, when there is uniform geometry, suppose I get the axis is running in the center x and y directions, and when the symmetry is the same, when I cut it into two halves, the symmetry should be equal. Then the centroid and the geometric center will be the same, right? That is what he is saying. The two only exist at the same 3D point when the path has uniform geometry and density. Uniform geometry and uniform density. Moment of inertia. An object opposition to changing its motion about an axis. This property is most often used when calculating the deflections of beam. And also, we simply teach, but we are not using it anywhere. So we have to use it. Product of inertia, so x, y, z directions. Radius of gyration. So you know, radius of gyration is nowadays they are using it in the two-wheelers also. The gyration concept is used where it balances itself. So they have invented one bike with the gyration gyroscope, and it can, even if it is moving, falling down this side or that side, it will stand and it can balance itself with the help of this concept. From the axis where all mass is concentrated, and will produce the same moment of inertia. Principal axis, principal moments, all these things. So these are all the very preliminary concepts where we go for the mass property analysis. Generally, this is what? mouse வந்தா தான் mouse work ஆகும். This is another I have taken. If you want, you can take down all these details, and this one you can take, and this also tolerance analysis, and it is nothing but the calculations that we do: length, area, surface area, curvature length. The formulas are there. So many formulas are there. You can work on it. Involves masses, centroids, and inertial property, momentum, property mapping and evaluation. Property mapping. So property mapping and evaluation is a continuous system, as all the curve, surface or solid equation and other geometric equations are stored with respect to the system. General mapping matrix is done. Newton Cotes quadrant is not very good. Newton Cotes quadrant and Gauss quadrant are used for property evaluation. So there are two general: Newton Cotes quadrant and Gauss quadrant are used for mass property evaluation. This will help you out. See, I am just giving you everything in a nutshell, so that you please go and see what exactly all this. Because there are several formulae and the derivations are there. If I have to take for the whole day. So I think time is a constraint now, and let us try to wind it up. Gauss quadrature are used for property evaluation. And there are other two rules are also there: trapezoidal and Simpson rules. Trapezoidal rules and Simpson rules are also used. Property mapping is there, property evaluation is there, right? Property mass, property calculation is there, calculation, mapping, evaluation. This comes one after the other. Calculation, first product design, then mass calculation, from there mass evaluation, from there mapping, then evaluation. Then only I can say the product is capable of withstanding the pressure, temperature, etc. Right? If I want to if I want to design a front absorber, what do we call it? As in the car we have got the bumper, right? So can you tell me how much load it can withstand? That has to be designed, right? So the bumper is kept as a safety device. What is the use of that one? Yes? To avoid collision. Even if it is if there is a collision, what is the maximum load that it can withstand? Force it can withstand. That is the purpose of the designing, no? So if the mass is very less there, what will happen? I am designing a product. What is the purpose of the product? To avoid collision, and even if it collides, what will be the maximum load that it can take to protect the car? So here mass property calculation comes in, then mapping comes in, evaluation comes in. So I should have a high mass so that to withstand a lot of load, or at least I should use a material where I have to design with a composite material where it is less mass and more appropriate for the using in that place. So the place where we use it, the product design, the products where we use it, and the design and the mass should be appropriate where we are going to use it. What is the utilization of it? Nowadays they have designed the cars, with not opening this way, right? It rolls up. In WhatsApp we have got that. Nowadays I think Mercedes or some company has, it just opens from, like an elevator, it moves up, right, on both the sides. And again automatically it rolls down. Like shutters only. Like shutters, it just moves up and moves down. And the car, they have come up with the car, I think in Indonesia somewhere, you can turn around 360 degree. 360 degree. So the wheels can be turned, and there is no need for you to just take a 4-meter turn or U-turn or 3-meter turn. Straight away you can just turn and drive back and go. There is no need for you because of space constraint. People are thinking about how can I, without moving my car, without turning my car. The turning radius is becoming less and less nowadays. But still, because of power driving and all that, power system, power driving, power steering, and I want in cities. I don't want. I have no space to turn my car. Right, 4-meter radius or 2-meter radius. I just want to turn the wheels and I have to move back and go. Right. So this is how they have designed and it is they have patented it. I saw it, and if you want, you check it in the internet. So right. So they have sent in WhatsApp. Again the same. Why I have to have a door of 1 meter this side and this side? I don't want space constraint. So I want like shutters. I want the doors to open and people come out, and again automatically it goes down when I switch off the button. So mechatronics is used, mechanical is used, and everything is combined in order to bring down the mass of the weight of the car, vehicle. Mass property calculation. There is mass property evaluation, mass property mapping. Then finally I am going to optimize. Optimization is also there now. Optimization I have. Composite objects. What are the properties of the composite? Just now I was giving an example. The application of the product. I don't want a bumper that is too heavy. Okay. So what is that I am going to go? I am going for an alternate material. The material that I am going to design will be of composite. The composite has to withstand a lot of collision or withstand a lot of load or crushing strength. I can say all mechanical properties, right? So I am going for a composite object. So what is the mass property calculation? How I am going to do this, right? So with this, I have given a nutshell of various the mass property calculations and the tolerance analysis. So there are about 5. So let me come back to the so it's defined as the definition. This is, we have got 5. The types, tolerance analysis types. So tolerance you know very well. These analysis types are there. This is very much useful for research scholars, and taking for BTech, BE, BTech and ME, we can give these kind of very topics, small topics. Ask them to take data and do a study arithmetic method. So that will give them excellent knowledge, and ask them to do a statistical method. That will make them work on the practical application or work. Let them go to a job shop. Let them go to a center where things are machined. You ask them, take them samples and ask them work on this. And Monte Carlo simulation method, of course we need some additional inputs to be that. And Takuchi method, we give a very small example and ask them to work on it. That will again give a very good project, right? For BTech level, there is no need for us to go further. So all this we have seen. And mass property calculations, you know. Ask them to take one very simple component in from a bike or from a car. Ask them to find out what is the mass of it and how you can reduce it. What are the other alternate materials they can put it so that the mass is reduced, but the functionality should be the same, or it should be better. The functional aspects, it should be better than the previous one, or even if it is equal to, no problem, right? So like this you can give some work for your students. It will be really nice, right? Okay, is time up, madam, or okay? Thank you very much, and
very much thank you, sir, for being with us in this session. And actually, we have brought with several hindrances since the consent I received from him to this. Thank you very much, sir. For assembly after lunch, we got some of data. We will go to some other start just doing that.
every pixel will be calculated based on the x and y axis. So with the help of the x coordinate and y coordinate only, the pixel will be fixed on that particular screen location. So the pixels will be the major important role for giving an input to the computer graphics. So and then for filling out the colors, you are going to use some syntax. For displaying some text and all, you are using the put pixel. So for each and everything there will be some separate syntax there. So you can utilize that and you can display. Apart from that, CRT tube. I think you are here about this CRT tube area, cathode ray tube. So everything, initial stage we are using this CRT tube based on the electron beams ejected on the screen only. The different types of colors will be emitted on the screen. So and then there are different types of scans are available, raster scan and the random scan. So you are aware about the on and off situation. So based on the electron beam that strike on that particular screen means you will get a different types of colors. Okay. So and then ellipse drawing, there are famous algorithms like resonance line drawing algorithm, resonance Sutherland Boachman polygon clipping, and polygon clipping. So many algorithms are there, and we are mainly focusing on 2D, 2-dimensional. 2-dimensional means it's both the x and y axis. To go for 3-dimensional means the x, y followed by the z axis. The z axis will be perpendicular to the x and y axis. So we are doing all the programs in the Turbo C. So the remaining 2 programs, say for that 3D representation and all, we are going to do in the Visual Studio. Means generating fractal images. We heard about these fractals, similar representation of objects. So fractals also very important booming thing in the computer graphics part. Yes. So 3-dimensional, in 2-dimensional, what we are going to do now? We are going to how we are going to translate the object from one position to another position, and for the scaling parts mean moving the that means if say for example if the particular object will be size of 2, 5, it will be obviously enlarged to be some other. If it's moved from one position to another position, automatically the size of the object will vary. So that will comes under the scaling. So translation, scaling, and then rotation. Rotation means you are moving the object from one angle to the another angle. That means so for you are rotating the object with the help of the theta. So 3-dimensional also similar to that, but you are going to consider one more axis, the z-axis. So these are the overall idea of what you are trying to do in our lab. So 2D we are having that translation, rotation, and ellipse drawing, resonance line drawing algorithm, and 3D and then Sutherland Boachman polygon clipping algorithm. So clipping and all, I will give you an introduction about this clipping. So clipping means you are going to focus all those objects within a screen itself. If the particular object is going beyond that screen means what you are trying to do is just clip out that particular image of the object. So that is a concept of clipping. So which part or which position of the object should be displayed on the screen, that should be decided with the help of this clipping. Okay. And so based on some algorithm, we are calculating that and we are trying to fix out the which object or image should have been displayed. So clipping. So polygon clipping. Similarly, polygon clipping also similar to that of only. There are other clipping algorithms like the font clipping, character clipping, text clipping, and text, etc. So many clippings are available. So it's all the one definition is that we are trying to remove the unwanted portion of the display. Okay, now we see the session in our lab. So regarding how we are going to draw the line, resonance line, and how we are going to draw a line in these with the help of the system, right? And ellipse followed by circle. Okay, just come to the lab because in one system only we are installing.
whether you are going to see any animation or not.
So animation we are not going to see. We are going to see only about how you are going to draw a line, how you are going to draw a circle, ellipse, with the help of the C++. சரிங்களா, எப்படி ஒரு லைன் ட்ரா பண்ண போகிறோம்? நான் ஏற்கனவே சொன்ன மாதிரி பிக்சல் வழியாக தான் நம்ம பண்ண போகிறோம். We are going to plot a line with the help of a pixel. That too with the x-axis followed by y-axis. பார்த்தீங்கன்னா எப்படி நம்ம குவாட்ரன்ஸ் வந்து 4 half quadrants நம்ம பிரிச்சுருக்க மாதிரி ஒரு லைன் ஃபிக்ஸ் பண்ணும்போது அந்த குவாட்ரன்ஸோட ஹெல்ப் வச்சு தான் நம்ம என்ன பண்ண போகிறோம்னா ஒரு லைனை வந்து பிளாட் பண்ண போகிறோம். சரிங்களா? ஸோ இதோட அல்காரிதம் வந்து இதுதான் மேடம். சிம்பிள் நம்ம ஒரு எண்ட் பாயிண்ட்ஸ் வேல்யூஸ் வந்து சப்ளை பண்ணணும். இன்புட்டாக x1 y1 x2 y2. ஸோ அப்புறம் நம்ம கொடுத்துருந்த x1 y1 வந்து we have to assign over to x followed by y. அப்புறம் dx dy. ஸோ dx dyனா டிஃப்ரென்ஸ் பிட்வீன் தி x இன்டர்வல். ரெண்டு இருக்குது எக்ஸ் குவாடினேட்ஸ். ஏன்னா வந்து ஒரு பாயிண்ட் எடுத்திங்கன்னா there are 4 points. எக்ஸுக்குன்னு பார்த்தீங்கன்னா x1 இருக்கும் followed by x2 இருக்கும். ஒய்க்கு y1 இருக்கும் y2 இருக்குது. ஸோ ரெண்டு டிஃப்ரென்ஸை பேஸ் பண்ணி தான் we are going to plot one single line. ஓகேங்களா? ஸோ இப்போ dy is greater than dxனா சப்போஸ் அதுமாரி கிரேட்டராக இருந்ததுன்னா நம்ம வந்து dx வேல்யூஸும் followed by dy வேல்யூஸும் இது பண்ணிப்போம். ஸோ இந்த EXCH பார்த்தீங்கன்னா ஒரு ஃப்ளாக் வேல்யூன்னு சொல்கிறாங்க. ஸோ இனிஷியலாக இட் வில் பி செட் அஸ் 0. ஓகேங்களா? சப்போஸ் அது ரெண்டு இதுவும் நம்ம சேஞ்ச் கிரேட்டராக இருந்துச்சுன்னா 0 இருக்க வேல்யூ 1 நம்ம
மானிட்டர் கொஞ்சம் உட்காரணுங்க சார் எல்லாரும்.
ஏன் சார்?
ஒன்றும் ஆகாது சார், ஒன்றும் ஆகாது. நீங்கள் பயப்படாதீங்க. கேமரா போயிட்டுருக்கா? சரி, ஓகே.
ஸோ அது பண்ணிவிட்டு நம்ம என்ன பண்ணுறோம்னா அந்த ஃபார்முலாவில் மல்டிப்ளை பண்ணுறோம் சார். p is equal to 2x dy 2ஓட மல்டிப்ளை பண்ணுறோம், 2xோட மல்டிப்ளை பண்ணிவிட்டு ஸோ அந்த பர்டிகுலர் பிக்சலை வந்து எக்ஸ் குவாடினேட்லும் ஒய் குவாடினேட்லும் ஃபிக்ஸ் பண்ணுறோம். நெக்ஸ்ட் அந்த 1 நம்ம டேக் இது அதாவது ஃப்ளாக்ஸ் செட் பண்ண 0 வந்தது 1 ஆட்டோமேட்டிக்காக சேஞ்ச் ஆகுது. ஸோ SY வேல்யூஸ் அந்த இது சேஞ்ச் பண்ண அந்த ஒய் வேல்யூவும் ப்ளஸ் இந்த எக்ஸ் வேல்யூவும் நம்ம வந்து ப்ளேஸ் பண்ணுறோம். ஸோ P வந்து பார்த்திங்கன்னா டிஃப்ரென்ஸ் அந்த இதுக்கும் ரெண்டுத்துக்கும் இருக்க இதுன்னு உங்களுக்கு நான் வந்து ப்ரோக்ராமில் காமிச்சேன்னா இன்னும் கிளியராக இருக்கும். ஸோ இப்போ பார்த்தீங்கன்னா இங்கே வந்து we are doing with C++. ஸோ C++னால பேசிக்கலாக we have to do with the help of the IO stream. IO stream பார்த்தீங்கன்னா என்ன இன்புட் அவுட்புட் ஸ்ட்ரீம் டாட் ஹெச். ஓகேங்களா? அடுத்து கிராஃபிக்ஸ் டாட். இது வந்து பேசிக்கலாக கம்ப்யூட்டர் கிராஃபிக்ஸ்னாலே நீங்கள் வந்து இந்த ஹெடர் ஃபைல் வழி கிராஃபிக்ஸ் டாட் ஹெச் வழியாக தான் நம்ம போடுவோம். நெக்ஸ்ட்டு பார்த்தீங்கன்னா ஒரு ஃபங்க்ஷன்ஸ் இருக்குது. கெட் இன்புட்டு, புட்ஸ், கெட் ஸ்க்ரீன், கெட் சி, புட் சின்னு ஒன்று இருக்குது. ஸோ அதுக்கு வந்து நம்ம வந்து அதுக்குள்ளே இருக்க மெத்தட்ஸ் யூஸ் பண்ணோம்னா யூ ஹேவ் டு கோ ஃபார் திஸ் கோனியா டாட் ஹெச். ஸோ மேத்தமெட்டிக்கல் இந்த ஸ்டாரு ஸோ இந்த மேத்தமெட்டிக்கல் ஃபங்க்ஷன்ஸ்லாம் நம்ம யூஸ் பண்ணுறதுக்கு மேத் டாட் ஹெச் யூஸ் பண்ணுறோம். ஸோ சப்போஸ் நம்ம வந்து நெகட்டிவ் குவாட்ரன்ஸ் அந்த மாதிரி நம்ம ரீப்ளேஸ் பண்ணுறோன்னு வச்சுக்கோங்க. உள்ளே நம்ம ட்ரா லைன் வந்து 4 குவாட்ரன்ஸ் இருக்குது. ஸோ நெகட்டிவில் இது பண்ணால் இன்ட்டு சைன்ஸ்ன்னு நம்ம ஒன்று கொடுத்துட்டு அதில் வேல்யூஸ் நம்ம வந்து பாஸ் பண்ணிடுவோம். ஸோ நெகட்டிவ் இருந்தாலும் ஆட்டோமேட்டிக்காக அந்த பாசிட்டிவ் அது மாறிக்கும். அடுத்து வந்து இதுதான் இந்த மெத்தட்குள்ளே தான் அந்த 4 வேல்யூஸும் பாஸ் ஆகும். x1 y1 x2 y2. ஸோ இந்த வேல்யூஸ் பாஸ் ஆகும். நெக்ஸ்ட்டு பார்த்தீங்கன்னா வாய்ட் மெயின் இருக்குது. ஸோ இந்த மெயினில் பார்த்தீங்கன்னா இந்த 3 இதுதான் ரொம்ப இம்பார்ட்டன்ட். இன்ட்டு ஜிடி டிடெக்ட் கம்மா ஜிஎம்னு ஒன்று இருக்குது. ஸோ டிடெக்டோட வேலை பார்த்தீங்கன்னா the main function to be detect is to identify what are the existing graphic drivers in our turbo C. turbo C-யோட எந்த கிராஃபிக் டிரைவர் லிங்க் ஆகிருக்குன்னு பார்ப்போம். ஸோ இந்த மோடில் தான் போகுதா, ஸோ அதுக்கு வந்து GM இருக்கும். ஸோ இந்த கிராஃபிக்ஸ் டிரைவர்ஸும் கிராஃபிக்ஸ் மோடும் தான் மெயின் திங். இதுக்குன்னா நம்ம ஒரு சிஸ்டத்தை வந்து இனிஷியலைஸ் பண்ணிவிட்டு அந்த ஒரு பர்டிகுலர் கிராஃபிக் சிஸ்டம் வந்து சக்ஸஸ்ஃபுல்லாக ரன் ஆகிறதுக்கு இந்த இந்த ஜிடியும் ஃபாலோட் பை ஜிஎம் சொல்லுவோம். ஸோ இந்த டிடெக்டோட டிஃபால்ட் வேல்யூ பார்த்திங்கன்னா 0ன்னு சொல்லுவாங்க. சரிங்களா? ஸோ நம்ம இங்கே வாங்கின இந்த 4 வேல்யூத்தையும் என்ன பண்ணுறோம், இங்கே இன்டீஜர் மூலமாக பாஸ் பண்ணி விட்டுறோம். ஸோ அடுத்து இனிட் கிராஃப்னு ஒன்று இருக்குது. இனிட் கிராஃப்னா இனிஷியலைஸ் த கிராஃபிக்கல் சிஸ்டம் சொல்லுவாங்க. இந்த கிராஃபிக்கல் சிஸ்டம் இந்த 2 மோடு வழியாக தான் நம்ம இயங்கப்படுது. ஆம்பர்சன் ஜிடி ஃபாலோ பை ஆம்பர்சன் ஜிடி. ஆம்பர்சன் பார்த்தீங்கன்னா அட்ரஸ் ஆஃப் கிராஃபிக். இது வந்து ஆம்பர்சன் பார்த்தீங்கன்னா அட்ரஸ் ஆஃப் தி கிராஃபிக். ஸோ வாங்கின ஒவ்வொரு வேல்யூஸும் நம்ம என்ன பண்ண போகிறோம், we are going to print on the screen. ஸோ அதுக்கு வந்து you have to use the syntax called C out. ஏன்னா C++ பிரிண்ட் பண்ணுறது C out ஒன்று இருக்குது. இப்போ கெட்டிங் இன்புட் C++ பார்த்தீங்கன்னா Cன்னு இருக்குது. ஸோ இந்த 4 இதுவும் அதே மாதிரி வாங்கிட்டு ஸோ வாங்கின அந்த லைன்ஸோட கோஆர்டினேட்ஸ் இதுக்குள்ளே நம்ம பாஸ் பண்ணிவிட்டு x1 y1 x2 y2 இது பண்ணுறோம். நான் ஏற்கனவே சொன்ன மாதிரி இந்த கோனியா டாட் ஹெச் கோனியா டாட் ஹெச்சுக்கு வந்து கெட் சிஹெச். ஸோ நம்ம ஒவ்வொரு கேரக்டரும் நம்ம வாங்க என்ன பண்ணால் அது வந்து ஸ்க்ரீனில் வந்து பிரிண்ட் ஆகிட்டே வரும். ஸோ நெக்ஸ்ட் லைனில் ஆட்டோமேட்டிக்காக அதை வாங்கணும், அது பிரிண்ட் ஆகும். அதே மாதிரி வந்து ஒரு கிராஃப் வந்து இனிஷியலைஸ் பண்ணிவிட்டு அந்த இது பர்டிகுலர் கிராஃபிக்ஸ் அந்த இதை க்ளோஸ் பண்ணுறது ஹவு டு ஆட் ஃபார் தி க்ளோஸ் கிராஃப். ஸோ
ஸோ இது ரொம்ப மெயினானது. ஸோ நான் ஏற்கனவே இங்கே வாங்கினது தான் இங்கே பாஸ் ஆகும் இந்த x1 y1. திருப்பி என்ன பண்ணுறீங்க, அந்த x1க்கு x அசைன் பண்ணுறீங்க, y1க்கு y அசைன் பண்ணுறீங்க. அப்சல்யூட் பார்த்தீங்கன்னா இப்போ வந்து ஒரு 15.6 இருக்குன்னு வச்சுக்கோங்க. அப்போ என்ன ஆகும் உங்களுக்கு ஏபிஎஸ் அப்சல்யூட் வந்து ஏபிஎஸ்னால் 15.6னா 16 அது கன்ஸ்ட்ரக்ட் பண்ணும். ஸோ நம்ம அந்த y1 மைனஸ் y2 அந்த கேல்குலேஷன் அந்த இது பண்ணிவிட்டு அதில் ஏன்னா நீங்கள் வந்து பிகாஸ் யூ ஆர் கோயிங் டு பிளாட் எ பிக்சல் பாயிண்ட் வித் ஹெல்ப் ஆஃப் டெசிமல் பாயிண்ட் வழியாக தான் நம்ம பண்ணுவோம். ஸோ டெசிமல் இதில் வரும்போது மைனஸ் ஆகிட்டு டெசிமல் பாயிண்ட் வந்தாலும் என்ன பண்ணோம்னா அதை ரவுண்ட் ஆஃப் பண்ணிடும். ஸோ ஏபிஎஸ் அதுக்காக யூஸ் பண்ணுவோம். ஸோ அந்த மாதிரி நெகட்டிவ் சைன் வந்து வரும் உங்களுக்கு. ஸோ அதையும் என்ன பண்ணிடுறீங்க, பாசிட்டிவாக இது பண்ணுறது தான் சைன்ஸை நம்ம யூஸ் பண்ணுவோம். ஸோ இது பண்ணிடுவோம். நான் ஏற்கனவே அந்த அல்காரிதம் சொன்ன மாதிரி இந்த டிஒய் விட அந்த டிஃப்ரென்ஸை விட எக்ஸ் கிரேட்டராக இருந்தோன்னா ஒரு டெம்பரரி வேரியபிள் வந்து செட் பண்ணுறோம். தட் மீன்ஸ் டெம்ப் இஸ் ஈக்குவல் டு டிஎக்ஸ். இந்த டெம்பரரி வேரியபிள் தூக்கி நம்ம என்ன பண்ணுறோம்னா டெம்பில் போடுறோம். ஸோ ஆட்டோமேட்டிக்காக என்ன ஆகிடும், டிஎக்ஸோட வேல்யூ வந்து எம்டியாக இருக்கும். ஸோ திருப்பி நம்ம என்ன பண்ணுறோம், டிஒய் வேல்யூ தூக்கி டிஎக்ஸில் போடுறோம். திருப்பி என்ன பண்ணோம்னா டிஒய் இதுனா திஸ் இஸ் பிகாஸ் ஃபார் இன்டர்சேஞ்சிங் த வேல்யூஸ் ஆஃப் டிஎக்ஸ் அண்ட் டிஒய். ஏன்னா நம்ம என்னென்னா டிஒய் வந்து கிரேட்டராக டிஎக்ஸாக இருந்துச்சுன்னா ஸோ டிஒய் இருக்க அந்த அந்த சின்ன பெரிய வேல்யூ வந்து டிஎக்ஸுக்கு போகும். அப்போ தான் ஆஸ் பர் ரூல்ஸ் அதுதான். ஸோ அதுக்காக நம்ம அந்த மாதிரி பண்ணுறோம். அப்புறம் நம்ம ஃபைனலாக அந்த நான் ஏற்கனவே அங்கே டேக் செட் பண்ண மாதிரி அங்கே 0 இருக்கும் டிஃபால்ட்டாக, அங்கே EXEH தொட்டு 1ன்னு மாற்றணும். ஸோ இப்போ வந்து அது முடிச்ச பிறகு அந்த இதை மல்டிப்ளை பண்ணுறோம். ஒவ்வொரு வாட்டியும் நம்ம மல்டிப்ளை பண்ணிவிட்டு அப்புறம் ஃபார் I is equal to 0 I less than equal to dx. ஐனாலே நீங்கள் ஃபார் லூப்னாலே வந்து என்னென்னா 2 விஷயத்தை பண்ணும் சைமல்டேனியஸாக. ஒன்று வேல்யூஸ் இனிஷியலைஸ் பண்ணது, அதாவது கண்டிஷனை செக் பண்ணுறோம், ஃபாலோ பண்ணி இன்க்ரிமெண்ட் ஆகுது டிக்ரிமெண்ட். ஸோ சைமல்டேனியஸாக பண்ணோம். இப்போ நம்ம என்ன பண்ணுறோம், எல்லாத்தையும் கால்குலேஷன் பண்ணி முடிச்சிட்டோம். பட் வந்து என்னது கிராஃபில் வந்து பிக்சல் வந்து பிளாட் ஆகிட்டே வரணும் ஒவ்வொரு. ஸோ பிளாட் ஆகணும்னா நான் ஏற்கனவே சொன்ன மாதிரி யூ ஹவ் டு யூஸ் த புட் பிக்சல். அதான் வந்து சின்டாக்ஸ். ஸோ புட் பிக்சலில் போயிட்டு எக்ஸ் கமா ஒய் கமா இங்கேருந்து வாங்க அந்த வேல்யூஸ் இது பண்ணிவிட்டு கமா 15 அந்த வித் வேல்யூஸ் இருக்குது. சப்போஸ் வந்து EXEH இது சப்போஸ் மாறி இருந்தா அப்படின்னா இது வந்து 1ன்னு செட் ஆகிடும். ஸோ இங்கே இந்த லூப்புக்குள்ளே அது போயிருந்தோன்னா 1 = 1 அப்படி வந்ததுன்னா ஓகே ரைட். அப்போ y + = இது வந்து y + = sy. தட் மீன்ஸ் அது ஷார்ட் ஃபார்மில் எழுதியிருக்காங்க. பார்த்தீங்கன்னா y = y + sy தான். ஓகேங்களா, அது அன்னசரி நம்ம எழுத தேவையில்ல. ஸோ அதை வந்து இது பண்ணிக்கலாம். அடுத்து எல்ஸ் போட்டு x = x + sx தான் இந்த x + sx. அது மாதிரி p is greater than 0. ஸோ அந்த கண்டிஷன் இது பண்ணுறாங்க. இது நான் டயக்ராமெட்டிக் உங்களுக்கு சொன்னோன்னா உங்களுக்கு இன்னும் கிளியராக இருக்குது. ஸோ இதுவும் அதே மாதிரி தான் கண்டிஷன்ஸ் என்ன இது பண்ணியிருக்காங்க இன்ட்டு சைன்ஸு. இப்போ m is less than 0. இது mனா ஸ்லோப்பு. ஓகேங்களா, இது பார்த்தா m வந்து ஸ்லோப் ஆஃப் தட் லைன். ஸோ y2 - y1 by x2 - x1. ஸோ அது லெஸ் தென் 0னா ரிட்டன் -1 வரும். அப்படி இல்லைன்னா ஸ்லோப் இஸ் கிரேட்டர் தென் 0னா ரிட்டன் 1 வரும். எதுவுமே இல்லைன்னா டோட்டலாக 0 வரும். ஸோ இப்போ இப்படி தான் வரும் உங்களுக்கு x ஆக்சிஸ் y ஆக்சிஸ் x ஆக்சிஸ் y ஆக்சிஸ். ஓகே, இப்போ ப்ரோக்ராமில் போனீங்கன்னு பார்த்தீங்கன்னா ஃபஸ்ட்டு ஸ்டெப்பை நம்ம அந்த மாதிரி இருந்தது ஒரு வேர்ட் டாக்குமெண்ட். வி ஹவ் சீன் தட் வேர்ட் டாக்குமெண்ட் ரைட்டுங்களா. ஸோ அந்த ப்ரோக்ராம் நம்ம காப்பி பண்ணியாச்சு. இப்போ எப்படி போட போனால் ஒரு ரன்னில் போய்க்கோங்க. நோட் பேடில் இது பண்ணிவிட்டு நோட் பேடில் போய்ட்டு நீங்கள் என்ன பண்ணிங்கன்னா சிம்பிளாக அந்த ப்ரோக்ராம் வந்து இது யூஸ்வலாக நம்ம இது பசங்களுக்கு இந்த மாதிரி கொடுக்க மாட்டோம். அவங்க சொல்லுறதுக்காக ஜஸ்ட் அதை காப்பி பண்ணிக்கோங்க. காப்பி பண்ணிவிட்டு அது பேஸ்ட் பண்ணுங்க. ஸோ இது சி ப்ரோக்ராம் நிறைய பேர் மிஸ்டேக் பண்ணுறது என்னென்னா அந்த C+ இது வந்து iostream.hன்னு வரதுனால நீங்கள் வந்து .cppன்னு கொடுக்கணும். சேவ் கொடுத்துட்டு இப்போ இதை என்ன பண்ணணும்னா டர்போ சியில் நம்ம இப்போ ரன் பண்ணுறோம். டர்போ சியில் ஸோ அந்த டர்போ சியில் ரன் பண்ணுறதுக்கு முன்னாடி நம்ம எதுக்குள்ள அந்த டர்போ சி இருக்கும் பார்த்தீங்கன்னா மை கம்ப்யூட்டரில் இருக்கும். மை கம்ப்யூட்டரில் லோக்கல் டிஸ்க் சிக்குள்ளே டிசின்னு ஒன்று இருக்கும். சரிங்களா, டிசிக்குள்ளே பின்னு ஒன்று இருக்கும். இந்த பில்லுக்குள்ளே தான் எல்லாமே உங்களுக்கு இருக்குது ரைட்டுங்களா. நீங்கள் பண்ண போகிற ப்ரோக்ராம் எல்லாமே அதுக்குள்ளே தான் இருக்கும். ஸோ இப்போ பார்த்தீங்கன்னா C++ இந்த ப்ரோக்ராம் இருக்குது கரெக்டுங்களா. இதை உள்ள நீங்கள் வந்து இது நிமோனிக்ஸ் அந்த மாதிரி இருக்கும் உங்களுக்கு அது உள்ளே பார்க்க முடியாது. ஸோ இதை காப்பி பண்ணி இந்த பின்னுக்குள்ளே போட்டுடணும். எந்த இப்போ ஒரு டர்போசி எங்கே இருந்தாலும் ஃபர்ஸ்ட் ஆஃப் ஆல் அது வந்து பின்னுக்குள்ளே என்ன ப்ரோக்ராம் இருக்குதோ அதை பார்த்து தான் ரன் பண்ணணும். சரிங்களா. ஸோ இப்போ இந்த ஃபைல் வந்து ரீப்ளேஸ் ஆகிடுச்சு. அதேமாதிரி இப்போ மற்ற ஆர்டினரி சி ப்ரோக்ராம்லாம் ஆட்டோமேட்டிக்காக ரன் ஆகணும். அது வந்து பிரச்சனையே கிடையாது. இது வந்து இன்ஸ்பெசிஃபிக்காக பார்த்தீங்கன்னா உங்களுக்கு இது வந்து கிராஃபிக்ஸ் இருக்கிறதுனால உங்களுக்கு வந்து பிஜிஏ டிரைவர்னு ஒன்று இருக்குது. ஸ்பெஷலாக ஒன்று இது பண்ணிக்கலாம். இதில் இந்த கிராஃபிக்ஸ் கார்டோட டிரைவர் நான் ஏற்கனவே சொன்ன மாதிரி இந்த GDGM சொன்னோம் பார்த்தீங்களா கிராஃபிக்ஸ் டிரைவர். ஸோ இந்த ஃபைல்ஸோட சப்போர்ட் வழியாக தான் என்ன பண்ணுது அந்த இது வந்து ரன் ஆகும் ப்ரோக்ராம். இல்லைனா உங்களுக்கு வந்து இந்த எரர் அடிக்கும். கம்பைல் டைமர் 2 எரர் இருக்குது மேடம் மொத்தம். ஒன்று வந்து கம்பைல் டைம் எரர், ஒன்று ரன் டைம் எரர். ஸோ ப்ரோக்ராம் வந்து கரெக்டாக எக்ஸிக்யூட் ஆனாலும் கம்பைல் டைம் எரர் அடிக்காது. பட் வந்து என்னது இந்த டிரைவர் இல்லைனால இதனால உங்களுக்கு ரன் டைம் எரர் அடிக்கிறதுக்கு வாய்ப்பு. ஸோ அதுமாதிரி கிளாஸ் லிப்பு, இந்த லைப்ரரி ஃபைல்ஸ் ரொம்ப ரொம்ப இம்பார்ட்டன்ட். டி கிளாஸ் லிப்புன்னு இருக்குது. ஸோ இதெல்லாம் வந்து கிராஃபிக்ஸோட சப்போர்ட் பண்ணுற லைப்ரரி. ஸோ இந்த பிஜிஐ மோடு வழியாக தான் அந்த லைப்ரரி ஃபைல்ஸு எல்லாமே வந்து இஸ் ஒர்க். சரிங்களா? ஸோ இப்போ நம்ம இதில் போட்டாச்சு. நெக்ஸ்ட்டு இந்த லைப்ரரியில் அந்த ஃபைல்ஸ் இப்போ நீங்கள் இதிலே போயிட்டு பின்னுக்குள்ளேயே பார்த்தீங்கன்னா இந்த ஷார்ட்கட் டு எம்எஸ் தாஸ் ப்ரோக்ராம் ஒன்று இருக்கும். சரிங்களா? இதை நீங்கள் இப்போ இது பண்ணிவிட்டு ஃபைலில் போயிட்டு பார்த்தீங்கன்னா ஓப்பன் அப்படின்னு கொடுத்துட்டிங்கன்னா ஏற்கனவே நம்ம என்னென்ன ப்ரோக்ராம் இது சப்போஸ் வந்து அது .c இருக்கும் சம்டைம்ஸ், நீங்கள் ஒன்றும் ப்ராப்ளம் இல்லை. அது star.cpp அப்படின்னு கொடுத்தீங்கன்னா அதோட .cpp கரஸ்பாண்டிங் ஃபைல்ஸ் எல்லாமே டிஸ்பிளே ஆகும் உங்களுக்கு. ஸோ இப்போ நம்ம ஆனந்த்.cpp இதில் போயிட்டு ஓப்பன் அப்படின்னு கொடுத்துட்டிங்கன்னா வந்துடும். ஸோ இதோட மெயின் அட்வான்டேஜ் பார்த்தீங்கன்னா, டர்போசியோட மெயின் அட்வான்டேஜ் பார்த்தீங்கன்னாலே நீங்கள் வந்து நீங்களே செல்ஃப் ஸ்டடியே பண்ணிக்கலாம். ஏன்னா ஹெல்ப் ஃபைல் வந்து வேறு எந்த இதுலேயும் அந்தளவுக்கு கொடுக்க மாட்டாங்க. இது மேலே வச்சு நீங்கள் ஜஸ்ட் வந்து ஒரு லெஃப்ட் கிளிக் பண்ணிவிட்டு அப்படியே ட்ராக் பண்ணிங்கன்னு வச்சுக்கோங்க. ரைட் கிளிக் பண்ணிங்கன்னா அதோட பர்டிகுலர் ஹெல்ப் ஃபைல் வந்துடும். ஸோ அதுக்கான ரிலேட்டிவ் சின்டாக்ஸ் எல்லாமே உங்களுக்கு வந்துடும். சப்போஸ் நீங்கள் ராங்காக போகணுன்னாச்சா அதுக்குள்ளே போய் பார்த்துக்கலாம் உங்களுக்கு. ஓகேங்களா? ஸோ இந்த டிடெக்ட்டுக்கு அந்த மாதிரி கொடுத்துருக்காங்க. ஜிடி டிடெக்ட்டுக்கு என்னது ஆக்சுவலி ஏன் இந்த மாதிரி டிடெக்ட் கொடுத்துருக்காங்க அது மேலே வச்சு ரைட் கிளிக் பண்ணிங்கன்னா, ஸோ பேசிக்காக டிடெக்டோட டிஃபால்ட் வேல்யூ 0. பிஜியோட கிராஃபிக்ஸ் டிரைவர்ஸ் ஆட்டோமேட்டிக்காக இப்போ நீங்கள் எங்கே வேணால் அந்த பிஜிஎஃப் ஃபோல்டரை எங்கே வேணால் கொடுத்துக்கலாம். நீங்கள் டிடெக்ட் நீங்கள் செட் பண்ணிட்டீங்கன்னா ஆட்டோமேட்டிக்காக அது எங்கே இருந்தாலும் அதை வந்து ஃபெச் பண்ணி உங்களோட ப்ரோக்ராம் சப்போர்ட்டிவ் அந்த இதை வந்து ரன் பண்ண ஆரம்பிச்சோம். ஸோ இதெல்லாம் வந்து ஹைலி அட்வான்ஸ்ட் அந்த இது கிராஃபிக்ஸ் அந்த கேம்ஸுக்கு அதுக்கெல்லாம் அது யூஸ் பண்ணுவோம். இதை நம்ம ஒரு நார்மலாக ஒரு லைன் சர்க்கிள் எலிப்ஸ் அது வரையிறதுனால இந்த டிடெக்டே மோதன் எனக்கு. சரிங்களா? நெக்ஸ்ட் அதே தான் அந்த ப்ரோக்ராம் x1 y1 x ஆக்சிஸ் y ஆக்சிஸ் இது தான் ஃபுல்லாக இருக்கும். ஸோ புட் பிக்சல்ஸ் இந்த இது கம்பேரிசன்ஸ் நம்ம வந்து கம்பைல் பண்ணி பார்ப்போம். ஸோ கம்பைல் பண்ணால் அன்டிஃபைன் சிம்பிள். ஸோ இது கம்பைலேஷன் பார்த்தீங்கன்னா Alt F9 ஒன்று இருக்குது. அப்படின்னாலும் நம்ம கம்பைலும் கிளிக் பண்ணிக்கலாம். ஸோ இதில் வந்து அந்த x ஆக்சிஸ் y ஆக்சிஸ் வேல்யூஸை நம்ம வந்து கொடுக்க போகிறோம். ஏதோ ஒரு 100 அந்த மாதிரி ஒரு 100 150 200 ஸோ அந்த மாதிரி ஏதோ ஒரு வேல்யூஸ் நம்ம வந்து ஸோ இந்த மாதிரி லைன் வந்து ட்ரா ஆகுது. ஸோ இந்த 4 சைட்ஸ் குவாட்ரன்ஸ் வந்து இது பண்ணிவிட்டு ஸோ நம்ம அந்த கேல்குலேஷன் வந்து ஸ்லோப் ஆஃப் எம் வந்து கேல்குலேட் பண்ணுறோம். சரிங்களா? ஸோ இது வந்து அந்த எப்படி அந்த டிஎக்ஸ் டிஒய் அதுன்னு பார்த்தீங்கன்னா அது டேக்ஸ் மோர் டைம். அந்த ஸோ இந்த லெஃப்ட்டு ரைட்டு நெகட்டிவ்ஸ் இது கொடுத்தாலும் உங்களுக்கு ஆட்டோமேட்டிக்காக ஆக்சிஸ் வந்து ஸ்ட்ரெயிட் லைனாக நீங்கள் வர வைக்கலாம். பேஸ்ட் அந்த வேல்யூஸ் என்ன சப்ளை பண்ணுறீங்களோ அதுக்கேற்ற மாதிரி உங்களுக்கு ரியாக்ஷன். இல்லை ஸ்லோப்
இல்லை இன்புட்லேயே கொடுக்கலாம்னு நினைக்கிறேன். எக்ஸ் ஆக்சிஸ் வந்து சேம் வேல்யூ கொடுத்துட்டு ஒய் ஆக்சிஸ் சேம் வேல்யூ கொடுத்துட்டு எக்ஸ் ஆக்சிஸ் மட்டும் சேஞ்ச் பண்ணால் அது ஸ்ட்ரெயிட் லைன்
பண்ணலாம்.
ஒய் சிம்லர் கொடுத்துட்டு எக்ஸ் வந்து வேல்யூ பண்ணால் ஸ்ட்ரெயிட் லைன். இப்போ எக்ஸ் அதே சேம் வேல்யூ, ஒய் மட்டும் கொஞ்சம் 200 கொடுங்க சார். அதே சேம்
ஸோ இதே மாதிரி தான் சிமிலர்லி பார்த்தீங்கன்னா அதே தான் எலிப்ஸுக்கும் எப்படி இது பண்ணுறாங்க. ஸோ மேத்தமெட்டிக்கல் கேல்குலேஷன்ஸ் அதுதான் மெயின் சார். நீங்கள் அந்த இது தெரியணும் உங்களுக்கு. சி தெரிஞ்சிருந்தாங்க தான் உங்களுக்கு வந்து ஃபர்தராக என்ன பண்ண முடியும். ஸோ இந்த புட் பிக்சல் கெட் பிக்சல் ஸோ அந்த மாதிரி இது இருக்குது. இதுமாரி இது இன்னொரு ப்ரோக்ராம் பார்த்தீங்கன்னா எப்படி வந்து கலர் ஃபில் பண்ணுறது. ஸோ எல்லா ப்ரோக்ராமுக்கும் இந்த கிராஃபிக்ஸ் டாட்டில் ஹெச் ஹெச்டி லிப்பு ஸ்ட்ரிங்கு ஸோ இதே தான் உங்களுக்கு ஃபர்தராக ரிப்பீட் ஆகிட்டே வரும். பார்த்தீங்கன்னா இந்த ஜிடி கொடுக்கலாம்
யூஸ்னால் எடுத்துக்கோ இல்லைனா தொண்ணூற்றி போடலாம்.
ஸோ இப்போ வந்து கலர் எப்படி ஃபில் பண்ணுறது, ஸோ அதுக்கான ஒரு இது எம்டி ஃபில் சாலிட் ஃபில் கலர்ஸ் ஃபில் பண்ணுறது. ஸோ அதோட மெத்தட்ஸ்லாம் இதில் இருக்குது. நீங்கள் பார்த்தீங்கன்னா பேக்ரவுண்ட் கலர் ஃபில் பண்ண ஸோ ஒவ்வொரு இதுக்கும் அந்த நேம் வந்து கொடுத்துருப்பாங்க. 0னா பேக்ரவுண்ட் கலர்ஸ், 1னா சாலிட் ஃபில், லைன் ஃபில்னா 2. ஸோ திக் லைன்ஸுக்கு பார்த்தீங்கன்னா 4. ஸோ இந்த ஒவ்வொரு இதுக்கும் இங்கே மீனிங் வந்து ஹெல்ப் ஃபைல் பண்ணது பார்த்தாலே புரியும். ஸோ இதுதான் மேடம் இங்கே பார்த்தீங்கன்னா இப்போ சாலிட் லைன்னா உங்களுக்கு நல்லா டார்க்காக இருக்கும், டாட்டர் லைனாக விட்டு 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 உங்களுக்கு புள்ளியாக இருக்கும். அடுத்தது பார்த்தீங்கன்னா சென்டர் லைன்னா நடுவில் மட்டும் பாருங்கள் ஒரு டாட்டட் நடுவில் ஒரு சென்டர் லைன் இருக்கும். நெக்ஸ்ட்டு டேஷ் லைன் ஒரே ஈக்குவல் சைஸ்லேயே இருக்கும். ஒவ்வொரு லைனும் இது பார்த்தீங்கன்னா ஈக்குவலாக இருக்கும், வேரியேஷன் இருக்காது. இது யூசர் பிட் லைன்னா அந்த டாட்டா. ஸோ இது கலர்ஸ் வந்து ஃபில் பண்ணுறது ஒவ்வொரு ஸ்டைல்லையும் நம்ம வந்து எப்படி ஃபில் பண்ண போகிறோம். சாலிட் லைன், ஹேஷ்பெல், எல்கெஸ், ஸோ இந்த சிக்கன் லைன், கிராஸ் இது ஸோ எல்லாமே. ஸோ கிளியர்டு நான் ஏற்கனவே அங்கே சொன்ன மாதிரி அதே தான் பார்த்தீங்கன்னா ஜிடிஸ் ரிலேட்டு ஜிஎம் இன்டிஎஸ் க்ளோஸ் டாட் இது வந்து என்னென்ன ஃபீச்சர்ஸ் என்னென்ன இது இருக்குது அதை நம்ம பார்த்தோம். ஸோ அதே மாதிரி இங்கே பார்த்தீங்கன்னா அந்த பர்டிகுலர் இதில் நம்ம லிங்க் எடுக்கணும்னா நம்ம கரெக்டாக இதில் வந்து பாத் வந்து செட் பண்ணணும். C:/TC/BJ நம்ம இந்த பின்னுக்கு பக்கத்தில் பார்த்தீங்களா. ஸோ அதே மாதிரி இங்கே இருக்கணும். ஸோ ஏற்கனவே அது ஸ்க்ரீனில் வந்து அன்னெசரி ஏதோ இருந்தோன்னா அது கிளியர் பண்ண கிளியர் ஸ்க்ரீன் கொடுக்கணும். டிவைஸில் ஏற்கனவே வந்து இருக்கும். ஏன்னா சிஆர்டி டியூப் நான் ஏற்கனவே சொன்ன மாதிரி அதில் வந்து ஏற்கனவே ஃபெச் பண்ணி வச்சுருக்கோம். ஸோ அதுலேருந்து நம்ம கிளியர் பண்ணுறது கிளியர் டிவைஸை கொடுப்போம். இது அடுத்தது பார்த்தீங்கன்னா நீங்கள் இந்த இதெல்லாம் வரைஞ்சி முடிச்சிருப்பீங்க ரைட்டுங்களா. ஸோ அது பக்கத்தில் நம்ம வேர்ட்ஸ் வந்து இது பண்ணுறதுக்கு அவுட்டெக்ஸ் XYன்னு அவுட்டெக்ஸ் XY. ஸோ bar/S0 நீங்கள் ஒவ்வொரு ப்ரோக்ராம் போட்டு இது பண்ணி பாருங்க. ஸோ டோட்டலாக ஒரு 8 ப்ரோக்ராம்ஸ் இருக்குது
சார். இது வந்து லைனு இப்போ நீங்கள் கலக்கிற கிராஃபிக்ஸ்னால் வந்து ஃபுல்லாக ஒரு ஆப்ஜெக்ட் க்ரியேட் பண்ணுற மாதிரி இருக்கும். அதுக்கு இது பேசிக்காக சார்.
ஆமாம் ஆமாம். நீங்கள் ஒரு ஆப்ஜெக்ட் ஃபுல்லாக இது பண்ணணும்னா
இப்போ ஒரு ட்ராயிங் வரைகிறோம்னா நம்ம ஒரு கேட்கமில் ஒரு கமெண்ட் கொடுத்து நம்ம ஒரு லைன் ட்ரா பண்ணுவோம். அந்த லைன் வரைகிறதுக்கு பேக்கில் இவ்வளோ ப்ரோக்ராம் ரன் ஆகுது.
நம்ம கேமரா பண்ணுறதுக்கு
அதுக்குள்ள பேக்கில் வந்து இந்த ப்ரோக்ராம் இவ்வளோ ப்ரோக்ராம் ரன் ஆகும். நம்ம ஒவ்வொரு லைனும் நம்ம குயிக்காக எடுத்து வரைஞ்சிருவோம். அதுக்கு பின்னாடி ப்ரோக்ராம் பெருசாக நீண்டே வரைஞ்சிக்கிட்டே இருக்கும். நம்ம வந்து அதுக்காக என்னென்னா யூசர் ஃப்ரெண்ட்லியாக இருக்கும். ஒவ்வொரு நேரமும் இந்த கோர்ஸ் யூஸ் பண்ண முடியாதுன்னு நமக்கு